You know that feeling, right? Your laptop just freezes, your smart speaker starts crackling for no reason at all, and we all do the same thing. We blame a software bug or maybe a bad Wi Fi connection. But what if the real culprit is something else? An invisible force, a sea of energy all around us that can turn our perfectly good electronics into unpredictable, glitchy messes. Well, today, we're pulling back the curtain on the very real, unseen consequences of radio frequency interference, or RFI. Now, everything we're about to get into comes from some really deep work. A technical report by the experts over at RFI Detectives, who are part of Virtualization Options LLC. This is actually the fourth part of our deep dive into their findings. And today, we are zeroing in on the fallout. What actually happens when RFI decides to show up? So let's just make this personal for a second. Have you ever had a device that just seems, possessed? The screen flickers, a file just refuses to save, the audio drops out for no reason. It feels totally random, right? Kind of like there's a ghost in the machine. Turns out it's not a ghost, it's just physics. And that brings us right to the absolute core of the problem. When we talk about the consequences of RFI, we're not just talking about weird behavior. We're talking about something much more fundamental: data being degraded and, worse, corrupted. See, when this unwanted energy gets inside a device, it really causes one of three major problems. First up, you've got performance degradation. That's when your system just slows to an absolute crawl. Second, you get data corruption, where the ones and zeros that make up everything, they get scrambled. And third, the worst case scenario, outright system failure. The whole thing just shuts down. Think of it like this. On the left, that's the world we expect, the world we paid for, right? Clean data, stable performance, devices we can rely on. But on the right, that's the world with RFI. It's a mess of garbled data, systems that are frozen half the time, and shutdowns that come completely out of the blue. And here is the most important thing to remember from all this. These are not just random errors. The next time your computer crashes, it might not be a simple software bug. It's very likely a physical symptom of an invisible force that is literally messing with the sensitive electronics inside. Okay, so RFI isn't just about our personal frustrations. When you take this problem into the commercial world, these little glitches, they turn into big financial headaches really fast. The cost of failure is absolutely real. And you can see this domino effect in action. It always starts small. So step 1, a tiny bit of RFI disrupts a single sensor on a factory floor. Step 2, because of that bad data, a huge production machine makes a critical error. Step 3, the safety systems kick in and halt the entire assembly line. And bam, step 4, the business is now just bleeding money from downtime and wasted materials, all because of one invisible glitch. And please, don't think this is just a factory problem. This risk is pretty much everywhere. We're talking commercial offices, where one corrupted file on a server can derail a whole project. Or think about retail stores. A point-of-sale system crashing during the holiday rush? That's a complete disaster. Even the massive data centers that power the cloud are dealing with this. When it's all said and done, it boils down to this incredibly simple and incredibly brutal equation. In any professional setting, downtime caused by RFI translates directly into lost money. It's that simple. But the stakes can actually get much, much higher than just dollars and cents. There's a critical threshold we have to talk about, where RFI stops being an economic problem and starts becoming a serious safety problem. This is where the consequences get terrifying. The report we're looking at puts it in a way that just stops you in your tracks. It says, for life-critical equipment, a random glitch is never random. It's a potential catastrophe. And when you're talking about human health and safety, there is zero margin for error. And just think about the arenas where this applies. Medical diagnostic gear giving a false reading, patient monitors in the ICU failing to sound an alarm, the safety controllers on heavy machinery malfunctioning. Even the automated systems in our cars are at risk. In these places, an RFI event isn't an inconvenience, it's a potential disaster, plain and simple. So what we're really seeing is that the consequences of RFI exist across this huge spectrum. And understanding that entire spectrum, from minor to major, is the absolute first step in learning how to deal with it. This table just lays out that ripple effect perfectly. At home, RFI is an annoyance, crackling audio, slow Wi-Fi. In the office, that same annoyance becomes a loss of productivity. On the factory floor, it's a direct financial hit. And in a high-stakes place like a hospital, that exact same invisible energy becomes a critical safety risk. Same cause, totally different outcomes. So the real takeaway here is this. You can't even begin to solve a problem until you fully grasp its potential impact. Recognizing that a tiny glitch in your living room could be an absolute catastrophe in an operating room, well, that's the foundation for actually doing something about it. Which, of course, leads us to the biggest question of all, doesn't it? If these are the consequences, ranging from just annoying all the way to catastrophic, how in the world do you find and how do you fight an enemy that you literally cannot see? We're going to start unpacking that in the next part of our series.